Hello and welcome back to the course. In our previous episode, we focused heavily on aesthetics. We styled our app using themes, custom fonts, and colors. We made the UI look good, but if you interacted with that app, you likely noticed a significant limitation. It was frozen. Nothing moved, nothing updated, nothing reacted. That is because, until now, we have exclusively used stateless widgets. In the rules of Flutter, a stateless widget is immutable. Think of it like a printed photograph or a painting on a wall. Once you paint it, you cannot change the color of a specific tree without painting the entire canvas all over again. It receives data once, renders it, and stays that way forever. But modern applications need to be alive. We need to track user inputs, timer ticks, network responses, and button presses, and so forth. To do this, we need to introduce a new concept called state. Put simply, state is just the data your application needs to display at any given moment. Data that can change during the lifetime of a widget. Today, we leave the static world behind. We're going to learn about stateful widgets and the most critical method in the entire framework, the setState method. Let's jump into code. I've cleared our previous project to start fresh. We are going to build a classic counter app, the hello world of dynamic interfaces. First, I want to show you the limitation of what we already know. We've already learned how to make a standard stateless widget. So let's start by doing that first. Firstly, we need to import our libraries, which is material Dart, which contains all of our styling options by default. Then we need to start our app from void main. Inside void main, we need to return a material app. Material app requires a home. Inside home, we can reference a widget. So we're creating a custom widget. Let's call it the counter screen widget. So this is currently an error because counter screen is not defined yet. So let's start by what we already know. We know how to make a stateless widget. So start by typing STLess and press enter. Name this widget counter screen. You've now created a counter screen widget. Inside the void main function, you're running an app, you're returning a material app, and in the home of the material app, you're returning counter screen widget. Your counter screen widget is a stateless widget. What does this widget return currently? Well, nothing. It returns a placeholder. What we do is we return a scaffold. This should be standard practice by now. You should have all of this memorized. We can start by creating an app bar. So to create an app bar, you simply give the app bar property. Inside the app bar property, you create an app bar widget. And inside the widget, you can have a few things. So the first thing we can have is the title. So under title, I want a text widget, obviously. And in the text widget, I want it to say state demo, for example. What are the other properties of a scaffold? A scaffold has a body. Inside the body, I want to return a center widget. The center widget could have a child. A center widget always needs a child. And under child, I want a text that simply says, let's say 0 for now. I want to edit the text style of this text so that it's a bit more visible towards the center of the screen. So I can do that by using the style attribute, and under style, I'll pass a text style widget. And inside the text style widget, I can set a font size. I can set a font size, suppose 50. If I run this app now, we will get a very simple application. This is our app bar. It is not centered on anything. That's why it is aligned to the left. It says state demo, exactly as we've said here. In the center, we have a text that simply just says 0 with a slightly larger font size than the app bar. Now, logically, if we want this number to change, we need a variable to store it, right? So let's start by doing that. So you want to add a variable. Let's try adding a variable directly inside our stateless widget. Int counter equals to 0. Counter equals to 0. I've added an integer called counter, but look at this. If you have your linting rules on, your IDE might already be complaining. It's telling you that fields in a stateless widget should be final. So if you hover over this, it will tell you that try making all of the fields final or removing the keyword const from constructor. Why? Because technically a stateless widget is meant to be immutable. It shouldn't hold any data that changes throughout the execution of the program. To fix this properly, we need to upgrade this class. This is where stateful widgets come in. We need a widget that is capable of maintaining state across multiple frames. We need a mutable widget. Watch this code closely. I'm going to use an IDE shortcut to convert this immediately. You could go in here and delete all of this and completely recreate it using a Stateful Widget, but that would be a long day. So let's immediately convert this using an IDE shortcut. Click on your class and this icon will appear. When you click on this icon, it simply says convert to stateful widget. If you click on this, your IDE will automatically convert your stateless widget into a stateful widget. This is the most confusing part for beginners. So let me break down what just happened. A stateful widget is actually two classes linked together. The top class, the counter screen class, is still immutable. It's just the configuration, the public face of the widget. So if I still try to create a variable inside here, int counter equals to 0, this will still be a mistake because technically this class is still immutable. But the beauty of stateful widgets is second class. The second class starting with this underscore counter screen state is where the magic happens. This class is what we called a persistent class. While the UI might get redrawn, this state object stays alive in memory. This is where we store our mutable data. Now, let's try to modify our data. I'm going to add a floating action button to our scaffold so we have something to click. So, a scaffold has another property called floating action button. When you create a floating action button, you pass in a floating action button widget. Inside the widget, you can have a few properties. So, the first property that is recommended is having a child. I simply wanted to have an icons dot add, let's say. Then a must for a floating action button is that it needs an on press property. So what is actually supposed to happen when you click the floating action button? Oops, seems like I've written location here. Let me just remove that and everything should be fine. Okay, on pressed, what we want to do is if you press the floating action button, which is a plus icon on the bottom of your screen, I want to increase this counter by 1. So I can increase it by either doing counter equals to counter plus 1, or the shortcut method of doing this, which is simply counter plus plus, which auto increments it by 1. For the current purpose, let's just print this out into our console. So print the value of counter into our console every time we press this button. If we run this application now, pay close attention to the console as I press this button. As soon as I press it, the value of counter is outputted into our console. So every single time that I press it, our counter is increasing by 1 and it is being printed into our console. But that is not the point of this application. We want this text in the middle of the screen to increase every time we press the button. Let's go back to our code. Right now under text, we're hard coding it to have a string that is 0. So let's remove that and let's pass in the variable counter. If we run this application now, do you think that this text will change if I press the counter button? No, it does not. Even though in our terminal we can clearly see that the value of counter is increasing, and in our code we've clearly given counter into the text widget, it still does not change. Why is that? The data in the memory is updating. So why is the screen lying to us? This happens because Flutter is highly optimized. It does not constantly check every single variable to see if it has changed. If it did that, your application would be extremely slow. Flutter assumes that if you didn't tell it to redraw the widget, so if you didn't tell it to rebuild or redraw something, the screen should stay exactly the same. We updated the variable, but we didn't trigger a rebuild or a redraw. To bridge this gap between our data and our visual interface, we need to use the setState method. The most important method in stateful widgets is the setState method. Technically, the value of this text is changing. The value of this text is currently 5, but it has not been updated into our screen because we haven't triggered a rebuild. So the way you trigger a rebuild is, under your on pressed, you need to wrap your counter logic. As you can see, the ID is automatically recommending it to me, but remove your counter incrementing logic. I'm wrapping my counter plus plus logic inside the setState closure. When we call this, we are effectively sending a message to the Flutter framework saying, hey, I just changed some data inside this state object. Please mark this widget as dirty and run the build method again. So what is a dirty widget? A dirty widget is when the UI components are not up to date with its variable components. So technically the value of counter was still changing, but the UI was not reflective of that. So that makes the widget dirty. What setState does is it marks the widget as dirty and runs the build method again. So it runs the build method again. When it reruns the build method, it updates the counter with the correct value. So if you run this now, you should see that the text in the middle of your screen should immediately update as soon as you press the plus icon. And it does. Immediate feedback. Here's the technical sequence of events happening in milliseconds. You tap the button. Firstly, the variable increments. Then the setState triggers. Flutter calls the build method again. The text widget is recreated, this time using the new value of counter. This cycle, event, state change, rebuild, is the fundamental heartbeat of almost every interactive app you will ever build. Let us summarize what we learned today. Stateless widgets are for static, non-changing content. Stateful widgets are for dynamic content that reacts to user input or data changes. State objects persist in memory to hold your variables, and the most important thing, setState is the trigger that forces Flutter to redraw the UI and reflect your changes. Now that we've made our app interactive, we need to make it beautiful and content-rich. In the next episode, we are going to dive into multimedia. I'm going to show you how to handle images, how to load them from your project assets, and how to fetch them from the internet using URLs. This is where your app really starts to come to life. Practice this counter logic, play around with it, and I will see you in the next video.